Here we have an ASUS VX7 Lamborghini version laptop that came in for repair. I did mention this in the past couple of videos. A customer brought it in. It's an older laptop. It used to be $4,000 or $5,000 back then. How old is the laptop? VX7, 2007, 2009. And I did tell the customer, this is a very complex laptop to work on. This assembly, reassembly, the board itself. And he wants the laptop restored and fixed at any price. So we took it in. It took a lot of time to remove the board from the housing. The screen is very complicated to work with, to take off the motherboard. And if you look here, the GPU is removable. It's a card that plugs into the motherboard. The CPU is removable. It's nice to see boards like this, right? Where you can replace the CPU, you can replace the GPU. A lot of laptops fail because of CPU-related issues or GPU-related issues. On this one, if parts are available, you can replace the GPU, you can replace the CPU. You have RAM slots in the front, you have RAM slots in the back. I mean, that's a fully loaded motherboard, and that's why those laptops were expensive back then. I do not know how much the VX7 is going today, but it's the Lamborghini version. The Lamborghini version. The king of all laptops back then. Fully loaded. Mailman just came in. Okay. Mailman just came in, picked up your packages. All orders that came in today. What time is it right now? Almost 3 p.m. All went out. So even if you ordered at 2:51, your order went out. Customer said, I want this restored at any cost, any price. He wants it restored. So if that's the case, if we're going to spend a lot of time working on an older laptop and the customer want to pay, by all means, we took it in. And one nice thing the customer did was he provided a donor board in case I needed any parts. And that's the donor board right there. It's stripped from the CPU, the GPU, no RAM sticks, but I can use it for parts if I need any parts from that board. Amazing. Amazing. That customer deserves an award because he makes our life a lot easier. Those are older boards, and most likely I do not have parts for them in case we need a specific part. So in some cases we may need to order the part from China if we're not able to source it from the US. Wait 2, 3 weeks, 4 weeks, 1 month. It's a hassle. I like to get things in and out, done, next. So where should we start? I mean, it's a board I have not worked on before, but it's a laptop's motherboard at the end of the day. So they all follow the same voltages or voltage procedures or layout. This one is different. Looking at the board, everything about this board is different. So we're going to have to figure it out. The first thing I want to do is plug a charger in. The customer did not provide a charger, but luckily we do have one in the shop here. The normal regular ROG ASUS charger will not fit, but I do have an older ASUS charger that works. Okay, right here. I do not see any lights anywhere on the board, but what we're gonna do is inspect the board under a thermal camera. That's number one, because I do not know where to start with a complex board like this, all modular, all bits and pieces, a lot of screws, a lot of ribbon cables, a lot of everything. The easiest way would be to start with a thermal camera and see if there's any signs of life on that board. If not, then we're gonna have to take it one step at a time and do like we do with the ROG laptops, inspect for a short circuit at the DC MOSFETs. And I do not see where the DC MOSFETs is on this one, the power connector MOSFETs. It's weird how that board is laid out. So we have a power connector right here. That's where the charger plugs in. Oh, look at this. What in the world is going on? The customer mentioned nothing about somebody tampering with the charging port, and that's a terrible job. A terrible job. What is this? The Hiroshima of all Hiroshimas. What's going on here? Right now, not only do we have to worry about possible faults on this motherboard that we need to look for, but we need to worry about the prior repair attempt and what the previous tech did. Two things to worry about. Hopefully the charging connector is the only thing that was worked on. And we got to make sure the charging connector is working properly before we proceed further. What if the problem is just the charging connector? How nice would that be? The question would be, are we feeling lucky today? So nothing obvious on front of the board. Let's flip the board. That's the charging connector, right? No, that's a USB connector. The charging connector is right over here. Super IO. No burn marks. We do have two MOSFETs here. And those are, you know what, let's not worry about those for now. We can test later. I just want to see if there are any signs of repair on the board other than the charging connector. And so far so good. Now we're going to use the real Flux, NF.Flux. Working under our NorthridgeFix microscope. And all the tools that we are using here you can purchase directly off our site, including everything from this amazing microscope, soldering station, the NF.Flux, tweezers, braid wick, power supply, thermal cameras, whatever you need. One-stop shop. Log into NorthridgeFix.com, click on shop, add to cart, checkout, pay, and we almost always ship out same day. That's our advertisement for today. In case you have not heard it for the 6 millionth time, we have new viewers every day. And this will keep going on until eternity because new viewers need to hear this every day. Most of you have already purchased from us. Thank you very much. But for those who are new to the channel and they are looking to get into this business, I've done the research for you. No need to look around, what should I buy, what tools should I buy. The tools that we sell are the tools that we use on our bench here. Some viewers get bothered when we advertise our products. You can either skip the talk, mute, or find yourself another channel to watch if you do not like to hear this. You would be selfish to just benefit from the video and not expecting the business to benefit from the viewers. That would be stupid. And I'm only talking about minorities. 95%, 97% of viewers, they understand and they support. And the other 3, 4, 5%, they like to complain. You cannot please everyone. We do not live in a perfect world. Fume extractor on. And let me grab a bigger tip. I feel like we need a bigger tip. The bigger the tip, the more heat transfer. Soldering iron at 430 degrees Celsius. We do not want to burn the board. We do not want to burn the flux. 430 is a safe temperature. And it's an effective temperature. Now those are anchor points, not a big deal. But while at it, let's fix them. But they do not affect the functionality of the signal in any way. They're just there to support that connector. How many ASUS laptops do we have on the bench here? That's a different one. It looks way too big. Okay, no, I've worked on this one before. So we have this one to work on, just came in. We have a lot to work on. We have this one here, and that's an ASUS laptop also. We have this one we need to work on, and that's a GEP. I do not work on those often. I've worked on them before, but not often. We have a ThinkPad we need to work on. And we have one more. And all those, they need to get done this week. All of them are expedited. Raise your laptop. That's aside from the video card that we have here. From the board that we got in yesterday, the bar light for a towing truck. A lot of work that we need to do. Not enough time. And look at how nicely the Flux cleans. Look at those joints. Look at the joints now and the joints before. Flux is what makes the difference, 100%. Of course, you need good quality solder and a good soldering iron, and not one that's gonna give out when you are soldering. You need the soldering iron that has heat compensation. The board is gonna absorb all the heat from the soldering iron tip. If you have 400 degrees on the soldering iron tip and you put that tip on the board and you do not have heat compensation on that station, what's gonna happen is the board is gonna absorb all the heat from the tip, and now the tip is at around 170 degrees and not at 400. There's nothing to compensate for the lost heat. And some viewers, they're right, I'm not able to melt solder. I'm not able to melt solder because you have a $10 soldering station. What are you expecting? The soldering station that we have on our site, the T3B, best value for the money. It heats up quick, heat compensation, 2 handles, 6 tips. What more do you want? Right, so we're gonna plug the charger in and we're gonna monitor the board under a thermal camera and see if there are any signs of life anywhere on the board. Whoa, look at this. First impression, I see something. First impression, I see something right over here with a tiny heat spot right on the side here. So what's here and what's here? This and this. What is this chip? RT8260A. Let me look up the diagram quick. Okay, so I found a PDF file. It looks like a low resolution PDF file, but we have VCC on the 3rd pin, right here on the left. A bit down we have VN, so we have to check VCC, we'll check VN. And where's V out? We can also check PVCC and V out right here. We can check P good. Where's enable? Enable 1 is down at the bottom. Let me check a few things and we can make a decision. Meter in voltage mode. So based on the diagram I have in front of me, let's check. Before we check anything, I need to plug the charging cable. Otherwise, we're gonna have zeros everywhere. Charging cable plugged in. The chip is probably burning hot right now, but what can you do? We need to test. Let's check for VN. Right here, that's the 3rd pin. We have 19.54 volts, so we do have VN. Let's check VCC. And we have 5 volts. Very nice. We do have enable, 3.2 volts. Let's check PVCC. We do have 5 volts. Let's check PG, 1, 2, 3, 4. Let's check V out, 3rd pin from the left. And what do we have at V out? We have 0.4 volts. And that's the wrong output. 0.4 volts is the wrong output. Now the customer did supply a donor board. This chip was also getting hot. But let's focus on the chip. Hopefully the donor board the customer provided is similar. And it looks 100% similar. We do have that chip, look, right here. I do not know if that chip on the donor board is good or not, but what we can do is, let's try this. Let me plug the charging cable into this donor board and let's check V out on this chip. So V out, how much are we reading on V out? And look at this, 3.485 volts on V out. Now one thing I noticed is PG on this chip is reading 3.2, but we did not have PG on the other chip. It's a 50-50 chance. It's possible that the problem is not the chip, but since we do have the chip, let's go ahead and replace it and see what happens. I do not like to play the guessing game, so I would rather replace and see if it works, especially that we do have a donor board. Let's start with the customer's board, remove the chip. And why not replace this component also? And I've got Flux. Let's check to see if we have V out. Hopefully we do. And we do not. We do not have feed G. So we are back to ground zero. No changes. After replacing the components, we do not have power good. Power good is missing. I knew it from the beginning, but I took the chance, replaced the chip, but we do not have power good. We measured power good on the donor board and we have it, but on this board we do not have it. I found a board view diagram for this laptop, so that's gonna help us to figure out what makes power good or where power good is connected to. I'll just change all the components, whatever it connects to. We do not have schematics, but we do have the board view diagram, and I feel like the board view diagram is much more important than schematics. SUS, power good, and I want to see where it connects to. It's connecting to this pin as well, so those two are the same. And on this side of the board, it looks like the only thing it connects to are those two components right here. Maybe we can start by replacing those components. Let me find them on the board quick, and right here. And it's a good thing we have a donor board. See how much it helps? Just imagine I want to order all those parts. Okay, so those components are replaced. Now we can measure and test again. Do we have power good now? And we do not. All right, we do not. No problem. Let's go back to the board view diagram. And I'm just doing this at random right now. We're gonna click on pin number 4. And the only thing that connects with power good on this side of the board are the two components that we already replaced. And nothing else on this side connects with that pin. And that's a good thing. Let's flip the board. And what connects to power good? Back of the board. It looks like this big IC. And we have few components here. Let's replace both of them. Not a big deal. And we're gonna replace both. So it could be an I/O issue because right now the board view diagram is pointing to the Super I/O chip. So again, the board view diagram shows those two components, 1 and 2. Let's not replace those two components. I highly doubt it's gonna be any one of those two. Let's replace the Super I/O chip because Super I/O chips are known to fail on laptops. Right, the chip is out. The anti-glare light on. Let's wick old solder. And why is my fume extractor off? Let's grab the donor. Alright, so we did an amazing job with the soldering. All we need to do is check all the pins and make sure they are making a connection. Then we can try to see if we have a pretty good signal. So far so good. All the pins are making a good connection. We did not use our soldering iron at all. We just reflowed with our hot air station. And we did an excellent job. Look at this, not even a single pin loose. And no two pins are bridging. Look at this better than factory job and tell me it's not better than factory. One take. First take. Done. Now I'm being very generous in the amount of time I'm spending on this laptop because the customer is paying for that time. And not even a single pin loose. We're gonna have to clean up, but let me just finish testing those pins. Not even a single pin is loose. Only at NorthridgeFix, right? Why am I so humble? I don't know, maybe I was born with it. When you can walk the walk and talk the talk, then you can show off, no problem. But do not show off when you have nothing to offer. Let's try it. Do we have P good? Yes, no, no, yes. Meter in voltage mode. And we're gonna measure the fourth pin. And the answer is we still have exactly the same issue. Exactly the same issue. So we have two more components showing on the board view diagram. Let's test. Meter in diode mode. What do we have here? 0.58, 0.58, and 0.52. Let me grab the donor quick. 0.58, good. 0.58 and 0.67. So on the customer's board we were reading 0.52. This one is reading 0.67. What if we go to resistance mode? Okay, so we have 100K. Let's measure the customer's board, and we are good on this one. So let's go ahead and replace this one. The reading is different. Charging cable plugged in, meter in voltage mode, and no change. Okay, so we exhausted all options right now based on the board view diagram, and at this point the only thing that could be causing pig good not to be present is most likely PCH. 99.9%, or let's make it 95%, it's a PCH related issue. It's Monday, back in the shop, nice and fresh. When I left the video, I told you the only other thing that could be causing an issue with this board at this point is the chipset, PCH. CPU on this board is removable, video card is removable, so PCH is known to cause issues on P-good. If we do not have P-good, we're not gonna have V out and the laptop is not gonna work. Now, one thing we can do is remove PCH from the donor board. We have a donor board that the customer provided and solder it onto this board. But one issue is we do not know if the PCH on the donor is good to begin with or not. We do not know unless we try. We're gonna have to remove the chip from the donor, remove the chip from the customer's board, rebuild the chip from the donor, solder it on the board. Then we can find out if that chip is working or not, or we can order a chip and wait for it to arrive. I do not know if they sell those chips, if we can buy them from the US or if we have to buy them from China. But even if you buy them from China used, you do not know if that chip is gonna be good or not. So right now what I wanna do is, before we replace that PCH, let's at least attempt to reflow that chip and see if it will make any difference. What are the chances, right? Just apply Flux all around PCH, and we're gonna reflow the chip. It's only gonna take a minute or two, and we will find out if that will solve the issue or not. I hope it will, so we don't have to spend any more time working on this board than we have to. And we're gonna reflow. Oh. What we're trying to do right now is liquefy solder balls under the chip with Flux applied onto that chip. And by solder balls liquefying, if there's one that's cracked or not making a good connection, it will make a good connection after it's reflowed. Right there. Okay, so that's enough. You see how I tapped on that chip and it pulled back, and that's a good thing. That's what you want to see. You want to tap on the chip and you want it to pull back. It means it's surface tension. The solder balls are going back in place. You tap it and they snap back in place. So that movement can make any cracked solder ball or any solder ball not making a connection with the pad under it solder back on the pads. You do not want to push it so much that it does not pull back. That's bad. It means the solder ball is out of place. A slight tap, it pulls back, and you are done. So what are the chances? See, the CPU is right here, and the CPU is removable. The video card installs right here, and I have it detached on my bench. And right now, all we need to do is plug in the adapter. And I hope we're gonna have something positive. Nervous and excited at the same time. How does that work? So We're gonna test pin number 3. Whoa. We have 3.2 volts. No way. I'm testing V out and we have 3.2 volts. We were getting 0.4 volts before because P good was not present. Can I show you both the multimeter and the board at the same time? It's gonna be impossible, but let me see. Let me try it quick, okay? Maybe I can split screens. All right, so let's do this. The camera is not gonna focus because it's focusing on my beautiful eyes. What can you do? I cannot help the camera. Let's go under the microscope, okay? Watch this. Watch this. We're gonna measure pin number 3 from the left, and that's V out. .2 volts. Are you kidding me? Let's measure P good. Pin number 4. What is P good reading? 3.2 volts. Again, P good. 3.2 volts. And we have a V out right now. If CPU was integrated, GPU was integrated, then it could have been any one of those integrated processors. But since PCH is the only one that's integrated on the motherboard, then that eliminates a lot of guessing. One final cleanup, and I'm gonna hand this over to Big Bus to reassemble and test. Now, it will be a big surprise if the laptop still does not work. At that point, I don't know if I should continue or not. We do have the signal on the chip now, so I don't think replacing the PCH is going to do anything, or maybe it would, but how much more time do I want to spend on this laptop if it still does not work? You have to know when to stop. I spent more than enough time working on this so I can help out the customer, but I cannot keep working on it forever. Let me hand this over to Big Boss to reassemble and test, and I'll be back to show you the final results. We reassembled the laptop, and I do not look too happy, right? Good and bad news. The good news is the laptop does power on right now, but nothing shows up on the screen. What can you do? Let me show you. Let me plug the cable in. I really had high hopes for this laptop. So the charging cable is plugged in right now. And it does have a CD-ROM, so you know. And just look here. Look at the light when I press on the button. Okay. The light came on. Nothing on the screen. We waited 2, 3, 4 minutes. And nothing on the screen. Cap lock's not working. Nothing on an external screen. We replaced RAM. We inspected everything that we could. And it's a black screen. At this point, maybe the video card, maybe the graphics card is bad. Who knows? Maybe the graphics card is bad. Maybe the PCH is bad. Maybe the CPU is bad. I think I exhausted all options. I'm going to call the customer to come and pick up. At this point, we do not have another video card to try. We do not have another CPU to try. I do not have another PCH to try. It's going to turn out to be a rabbit hole. I'm going to give up on the laptop. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video. Let me know what you would have done in my case. Would you continue? What would your next step be?